Okay, we're going to be looking into another least squares uh, item. Okay, this will be not with the least squares regression line, but the least squares quadratic polynomial. And we had dealt with the points 1, 4, 3, 10, and -2, -7. And on the basis of what we had with ax is equal to b, okay, we had an inconsistent system where the points were not collinear. And for the line of best fit, or in other words, the least squares regression line, okay, we had looked at that from earlier and using the transverse matrix A and using that multiplying A and X and setting that equal to the transverse of A and B. Okay, we had for the coefficients of the regression line, we had the constant C naught at 1/19. And for the X term, we had the coefficient to be 65/19. And again, just for the visual representation, okay, so we have with our 3 points, 3, 10, 1, 4, and -2, -7. And again, the least squares regression line we have at y is equal to 65/19 of x plus 1/19. And that is the straight line that is the closest to all 3 points collectively. Okay, now looking at progressing to the determination of the least squares regression quadratic polynomial solution for the data points. Okay, in other words, determining the equation of the parabola that is the closest to all the given points. And again, we have with the model, okay, this time we had that y is equal to c naught plus c sub 1x plus our tertiary element, which we have with c sub 2x squared, and just configuring items here and just displaying the commutative property of equality counterpart, okay, where we have c naught plus c sub 1x plus c sub 2x squared is equal to y. And with the same 3 points, now the first at 1, 4, so we're going to have, again, c naught plus c sub 1 times 1 plus c sub 2 times the square of 1 is equal to 4. Next, with the point 3, 10, okay, so you got 1 c naught plus c sub 1 times 3 plus c sub 2 times 3 squared, where we have respectively 3c1 and 9c2, and we have is equal to 10. And with -2, -7, okay, so you got c naught, and then we have plus c sub 1 times -2, whereupon we have -2 c sub 1, and then we have plus c sub 2 times the square of -2, which is going to be a positive 4, and we have is equal to -7. And now we have with the coefficient matrix, okay, we have 1, 1, 1 for the top row, and the elements in the second row we have with 1, 3, 9, and in the last row we have 1, -2, 4. And we have with the variable or the coefficient matrix, we have x equal to the 3 by 1 display, whereupon we have c naught, c sub 1, and c sub 2. And we have with b, we have also with the y values, again, which we had at 4, 10, and -7. And taking the transverse of a, okay, so we have 1, 1, 1, 1, 3, -2, 1, 9, 4. And taking the product, okay, where we have the transverse of A times the matrix A and multiplying together, and we are going to end up with the product with the 3 by 3 matrix, where the top row we have at 3, 2, 14, middle we have 2, 14, and 20, and the last row we have with 14, 20, and 98. And multiplying the transverse of A by the matrix B, okay, we're going to have for this output, we're going to have a 3 by 1 layout where we have the top number at 7, middle at 48, and the bottom number with 66. And setting things up, okay, where we have, again, the transverse of A times X is equal to the transverse of A times B. Okay, this is going to be our setup, and converting to an augmented matrix. Okay, so we have 3, 2, 14, 7, 2, 14, 20, 48, 14, 20, 98, 66, and just putting down the reduced row echelon form. Okay, so we got 1, 0, 0, 3 fifths, 0, 1, 0, 53 fifteenths, 0, 0, 1, -2 fifteenths. And so for the coefficients, okay, c naught is going to be 3 fifths, c sub 1 is going to be 53 fifteenths, c sub 2 is going to be -2 fifteenths. And for the quadratic polynomial, okay, we're going to have y is equal to 3 fifths plus 53/15 of x minus 2/15 of x squared. And looking at what we have on the display. So we have with these 3 points, okay, 3, 10, 1, 4, negative 2, negative 7. And we have with the parabola opening downward. Okay, again, we have y is equal to negative 2/15 of x squared plus 53/15 of x plus 3/5. And this one is going to pass through all 3 of these points. So while the linear regression line did not pass through all 3 points, okay, it turns out that the quadratic polynomial graph does.